Okay. Right, the curve C shown above has parametric equations as given. Find the coordinates of A, which is where? The point with this particular value of the parameter T.
Yeah.
Okay, so that's an easy thing just for 1 mark. Find the coordinates of the point A, which does look easier than on this occasion. That's all we were doing here, by the way, wasn't it? Find coordinates at particular values of T.
Yeah.
Looks a bit simpler this time. So the coordinates of A, where T equals -1. What about X?
T equals -1, X equals 1. No, yeah, no, X equals -1.
Nope.
Wait, oh, no. X equals, okay, agree, -1, take away -8, which means it would be 7.
Yes. And the Y value?
The Y value would be 1.
Yeah. Okay.
Yeah.
The line L is tangent to the C at A. Now we don't know exactly where that is, probably somewhere up here.
Yeah.
So let's say A is about here. And then to draw a tangent, I'll try and make a nice straight line if I can. But I wish they, oh, well, let's put it there. It's touching at that point there then. That might be all right. So the straight line, I don't know how I made that. Yeah. So let's say A is there actually, not there. Let's move that down. Go. Oh dear. Right, so let's say A is there and that's 7. I have no idea if it's realistic. Right. So this is the line L then, isn't it?
Yeah.
Tangent to the curve C at the point A where X is 7 and Y is 1 apparently. So that's very odd scaling, isn't it?
Yeah.
We did do it right, didn't we? -1 minus -8. 7. Yeah, fine. Good. Okay, so how shall we find the equation of this line and then compare it with their version?
Okay, so we can use the formula that you don't like.
Oh yes, you can do that. I don't want to put you off using that. You mean Y minus Y1?
Yeah, equals mx take away x1.
Yeah. Okay.
So y take away 1 equal. Actually, wait. We don't have the gradient, do we?
Not yet.
Okay, so we need to find the gradient. You can do that by is it differentiation?
Indeed. We want the gradient function.
Yeah.
Which we can examine at that particular value of t.
Yeah.
Because after all, our gradient function, which we're going to call what? What do we always call the gradient function for a function y in terms of x?
The gradient. What do you?
Well, if we think of this graph as an xy graph,
yeah,
then surely the gradient function is
dy by dx.
Yeah.
Yeah.
Okay, so the same routine. Because we don't have y to differentiate in terms of x,
yeah,
nonetheless, we know The dy dx, of course, is dy.
over dt and then over dx over dt.
Yeah. Okay. So dy dt.
Oh, dy dt 2t.
Good. Dx dt.
dt take away 8.
Oh, 3 what?
Wait,
Yeah, check that.
3t 2 1. Yeah, wait, oh no, it would be 3t squared take away.
Yeah. Take away.
Take away 8.
Yeah. I don't know why you.
Yeah, no, I was
Okay.
I was thinking as if it was squared in my head.
Fine. So which equals, for example, what particular example do we want of that?
We want I'm not sure.
All right. Perhaps you've lost your bearings. Where are we? How did we get here? Why did we come here?
Yeah.
Where are we? Well, we're looking at a what kind of expression?
We're looking at differentiation. I don't know.
Yes. We differentiated. We've got a derivative.
Oh yeah, we got derivative. Yeah.
What did we want it for?
We wanted it for the gradient
Of
of
well, the curve
of the curve. Yeah.
at a particular point,
Yeah.
which is going to be the constant gradient of the tangent at that point.
Yeah. So then I'm confused of what we're supposed to do next.
Yeah, where were we? What part of the problem were we on?
We need to wait. So we need to I'm not sure. I've lost myself. We need to.
Are you sure you can see the screen properly?
Yeah. I can see it.
Well, we were, we did part A.
Yeah.
We were doing part B, and then we started writing up here, didn't we?
Yeah.
Because we were trying to find the equation of a straight line.
Yeah.
And then you noticed, oh, we don't have.
The gradient.
That's why we were differentiating, isn't it?
Yeah. Oh wait. So are we using the numbers now? So is that the gradient? So the gradient is 2t over 3t squared minus 8.
The gradient function, yes.
Yeah.
Any
So
point on this curve is going to be 2t over that, yeah?
yeah. So then we would put that into the y take the y1 part.
Well, yes, put what in?
So m equals 2t over 3t squared minus 8.
Well, in general, for any point on the curve, that's the gradient.
Yeah.
But I mean, m was a bit more specific, wasn't it?
So it's when t equals minus 1.
Yeah.
So you substitute minus 1.
Yeah.
Oh. Yeah, I was thinking that, but then I thought that was for part A. Okay, so then if you substitute minus 1, we get minus so t equals minus 1, so we get minus 2 over 3 minus 8, which is minus 5. So then we get
and then you get, yes.
2 over 5.
Yeah.
So then m equals 2 over 5. So then y take away 1 equals 2 over 5 x
Right.
take away 7. So then 5y minus 5 equals 2x minus 14.
That's right. You're putting the if I hear you right. Oh, damn.
So 2x minus 5y and then minus 14 plus 5 minus 9 equals 0.
Yeah, I think so.
Yeah.
Sorry, I have stuff here. So you're ahead of me. So y minus that particular result of
1 equals 2 over 5 x take away 7.
Yeah, that's right. Well done.
So I times the y side by 5. So 5y minus 5.
Yeah, lovely.
And then equals 2x take away 14.
Lovely. Carry
and
on.
then I brought the 5y and the minus 5 to the right. So I've got 2x take away 5y take away 9 equals 0.
Oh yeah, good, good. Yes, you only have to. You're basically writing what they've got by then, aren't you? Minus 5.
Yeah.
That's correct. Yeah, you can get away with just writing what they've got, which is that, isn't it? Yeah. Good.
Yeah.
Fine. Yeah. It can be very easy to if you do a lot of exercises of that kind, you can be failing to grasp the point that the relationship between the gradient of a straight line tangent is going to be the same as the gradient of the curve it's tangent to at the point where it touches.
Yeah.
Okay, and the line L also intersects the curve at point B, which I guess is there, but I mean, I'm not sure if that's realistic.
Yeah.
Not at all sure. But anyway, it'll be interesting to see what it gives us. So yes, find the coordinates of B. How could we do that?
So would we just do the same thing again? Well, actually, wait. Also, find the coordinates of B. So we know the gradient of the whole thing. How?
Well, what do you mean by that? The gradient of the whole thing?
I mean, the 2t over 3t squared minus 8 is the gradient of the curve.
True.
At any point.
True.
So, how would you find a point?
How would that help us at B?
Yeah, that's what I'm trying to figure out.
I mean, I'm not saying I'm not saying it couldn't. I'm not sure, but it's not where I'm going with this.
Okay. Then I'm not sure.
But we're asking where a curve, set of points, for which we have an equation, cuts another curve, which is a straight line. I mean, it's not curved, it's straight, but we could still call it a curve, just a straight curve, if that makes sense. It's never quite clear whether we should call a line we should assume that line means straight, or whether curve means not straight. It can be either. Anyway, that's beside the point. We're looking for where one set of points intersects with another set of points. In other words, we're asking where two equations are true at the same time. We're not only on the curve satisfied by this equation, or set of equations, but we need to be satisfying this equation as well.
Yeah.
So two equations are true simultaneously.
Yeah.
Sound familiar?
Yeah. So we're making
This
we're
equation
making
is true.
we're making that equal to
Yeah. I mean, we like to call simultaneous equations a case of making two equations equal to each other,
yeah.
if we can. But that's usually
Yeah.
when, if we've made y or something the subject.
Yeah.
That's not ready to hand in this case.
Okay.
But we need to start from saying, okay, this is true. At the same time as these are true. So they're simultaneous equations.
Yeah.
And we just need to solve them
Yeah.
to find out
But
whether they're all true at the same time, simultaneously.
how would you? Okay. So how would you? Because you have it stuff that in terms of t, and then
Yeah, you can start to wonder that kind of thing. Yes, but
yeah.
actually, we one option, one good answer to that question is, we've got x here and y there.
Yeah.
So
So we
replace
can.
both of those, couldn't we?
So we make x the subject and y the subject of the formula, and then substitute it in
Well, they already are the subject of the parametric equations, aren't they?
the top one. For the top one, if you rearrange to find x and rearrange to find y. Oh, wait.
Yeah, I'm not denying you could do that as well. But
Oh,
x is already the subject
yeah.
of t
So
there.
we can have, yeah, so we can have 2 and then bracket t
Yeah,
squared minus. Oh, yeah.
absolutely, yeah.
2 cubed minus 8t and then minus 5 and then t, yeah, minus 5t squared minus 9 0. So we have 2t cubed 2t cubed minus 16t.
Well, let's put the square term next.
Oh, okay. Minus 5t squared
minus 16t
minus 16.
equals 0.
Yeah.
Okay, we've got a cubic to solve. There
Yeah.
might be 6 marks. So, what's a good place to start for solving a cubic?
Oh, so is it to get
I mean, we'd like to do what, if we can?
factorize?
Yes. So how do we start looking for linear factors of a cubic?
So is there something that
I mean,
from
it's really tough in a way if you've got no clues, because you've got to say, oh God, well, they're asking me to solve a cubic. I hope that one of the linear factors is t minus 1 or
yeah.
2 or 3 or t
Yeah.
plus 1 or t plus 2, etc.
Yeah.
So what we'll try now, if one of the linear factors was t minus 1,
Yeah.
then setting t to what would bring everything to 0?
Setting t.
No matter about the remaining quadratic,
Yeah.
if we set t to what value, we'd get 0, wouldn't we?
Yeah.
What value of t would send everything to 0?
T equals 1.
Yes. So if it's true that t minus 1 is a linear factor,
Yeah.
setting t to 1 would send everything to 0, wouldn't it?
Yeah. Yeah.
You can see that's not going to happen here, though, can't you?
Yeah. Because
I mean, mind you, let's try minus 1. That might work.
Yeah, so then we get -2.
So 2 times the cube of -1 minus 5 times the square of -1. It's not time wasted to do this, just in case. Find out what it is. So that will be -2.
-2. And then -5.
-5.
And then +16.
Yeah.
Take away 9 equals
Oh, damn.
2 -7.
I agree, yeah. Because that's -2. -5 is -7.
Yeah. +16.
Oh, no, sorry.
I'll just yeah. I didn't mean as that was my answer.
Yeah, sorry. What did we both say something wrong here, which led us to think it wasn't working out? Because
No,
that's -2, isn't it?
yeah, -2 -7 +16.
-7 plus 16 is
9. And then take in, yeah, 0.
Whoopee. Oh, well, that's a
Yeah.
result, isn't it? I mean,
Yeah.
yeah. I mean, the point is, you're stuck if you're not lucky soon. And in
Yeah.
A-level, you take it that a cubic, unless there's any other clues present, the cubic
Yeah.
ought to be that's, you ought to be that lucky, or soon after trying other. Yeah. Okay.
Yeah.
So we know that one of the linear factors of that
Yeah.
is so it's t. One of the linear factors is t what?
-1.
Ouch.
What?
-1 was the value of t, which was going to send everything crashing to 0.
Yeah.
Because the linear factor was t
Equals 1. T plus 1.
t plus 1. Good. The linear factor is t plus 1. Therefore,
Yeah.
the value of t sending everything to 0 is. And when we
Yeah.
talk about it sending everything to 0, of course, that's what you need to know, that's called the what theorem?
I'm not sure. Wait, the theorem?
The factor theorem.
Factor theorem. Yeah.
You're right. Yeah. The factor theorem. So anyway, we know that the remaining quadratic is going to look like what? How many t squared?
How many t squared?
In the remaining quadratic.
T squared.
Sorry?
Wait. 2t squared.
2t squared. You can see why. Good. And then we don't know how many t. Let's leave that blank. Leave a blank space.
Yeah, but we know it must.
The constant, sorry, yes, is
-9.
-9. So just by starting to imagine expanding that, that's going to give us t times 2t squared is 2t cubed as required.
Yeah.
Then it's going to give us some as yet unknown quantity of t squared.
Yeah.
Followed by a linear term, -9t, but followed soon after by another 2t squared, 1 times 2t squared, yeah?
Yeah, yeah.
So how many t squared did we need here then? Multiplying t by how many t? And then we get another 2t squared later on. And we needed it to total up to that -5t squared.
-5.
So this number here must be what?
Is it -3?
No, because then you'll be then in total you'll only be subtracting 1t squared.
Oh, so then -7.
-7.
Yeah.
So there's your quadratic.
Yeah.
And by the way, it is, we can set it equal to 0.
Yeah.
That was equal to 0, yeah.
Yeah.
And then, so we're into trying to solve this being equal to 0. So what would we do next?
Yeah.
I mean, we know one place where it's happening is -1.
Yeah. So would you solve the?
Actually, that's probably that point, isn't it?
Oh yeah. T equals -1. Yeah.
Oh no, because yeah, because that was 7. So that's
Yeah.
minus 1. So we know we're done. And we know that the quadratic is going to solve,
Yeah.
give a repeated root of 1.
Yeah.
Let's check that, though. Let's try factorizing.
Yeah.
Does it factorize? Could we say it's 2t times what times t times what? Oh no. Maybe it doesn't. It must do.
Yeah.
It must factorize if it comes out that as that simple result of t equals 7.
Yeah.
Must it? No, it wasn't t equals 7. It was x equals 7, and therefore t x equals 7. So it was a solution to that. Which is t is minus 1, isn't it?
Yeah.
So t will be but t was minus 1 here. So of course, no. How wrong was I when I said, look, we're probably done if we don't, but we ought to check. No, we ought to carry on.
Yeah.
I was confusing an x value of minus 1 with a t value of minus 1.
Yeah.
It could be very different. Yeah. So we do need to, that could be our previous result. This is something we ought to do now, but we don't know that it's going to factorize. It might not. So are there two numbers that multiply to make minus 18? You see what I'm doing there?
Oh yeah. Yeah. Yeah.
That multiply to make minus 18 and add to make minus 7? Well, yes, there are. So it will factorize.
Yeah.
Yes. So let's just try a bit harder here.
So 2t would be minus 9 plus 2.
You lost me. Sorry, I'm not sure. Are you factorizing? Are you getting numbers here?
2t minus 9 and then t plus 2.
Yes, I was doubting it when I was assuming this must be 3 and 3. I couldn't make it work. But you're right.
Yeah, 18 because of the 2.
So where's the 2 and where's the 9?
Does it matter?
Yeah, because of that 2. In fact, maybe I'm having my doubts about this now. You're right about I think you were redoing that bit, weren't you? And saying the numbers are
18, minus 18.
2, so it does work.
Yeah.
But how does it factorize then? What are our numbers here? It can't be 3 and 3. How can it be 2?
I thought it was
9 either. It can't be that either.
It can't be 9. I thought we're making it to minus 18, so we get we can use minus 9 times.
Oh, you're splitting the middle term. Well done. Of course, we needed to do. Well, I need to do it now anyway. Yes. So down 9 and up 2. And you're saying that's like t times 2t minus 9 plus 1 times 2t minus 9. So it is a 9 here.
Yeah.
And a 2 here. Like what you were... No, it's a 1 here. Of course it's a... What? Yes, of course that works. Oh! So is this what you were telling me?
No, I was saying 2, but yeah.
Yeah, and I was thinking 2, and I was getting totally confused. Fine. Therefore, and yes, the t value of 1, it makes sense that the t value of 1 was contrary to what I said, at A rather than B.
Yeah.
Because it's tangential there, so it's going to take up both of these this, what we'd call a repeated root.
Yeah.
So the answer we want is going to be the other part of it, where 2t minus 9 equals 0.
Yeah.
So this here implies either t plus 1 equals 0,
Yeah.
or else 2t minus 9 equals 0.
Yeah.
And you were telling me t equals 9 over 2, weren't you?
Yeah. Yeah, I think so.
I think so.
Yeah.
I think I hear those words echoing now. I was confused at the time. Excellent. So if t is 9 over 2,
Yeah.
and they wanted to know what? The coordinates of b?
B, so then you would substitute 9 over 2.
Yeah.
Okay, so x equals 9 over 2 cubed
Blimey.
minus 8 times 9 over 2.
Gosh.
Okay.
Hairy, isn't it? So,
Yeah.
so literally, the cube of 9 is going to be 981s are what?
981s.
Yeah, afraid
Oh.
so.
So wait, let me just write this up. Okay, so then we have we have 729
Well done. This is over
over 8.
good. Minus, well, we could cancel the 8 over 2,
Yeah.
but instead, I think we'll multiply the 8 by 4, or we've got 9 eighths, haven't we? Which I think we
Yeah.
multiply by 4, really, don't we? So that we've got 8 on the bottom.
Yeah. So
So we want 4 lots of 9 eighths or 72. 4 72s would be
288.
well done. So how many over 8 then?
Okay, then we have
300. 429 and put back 12.
441. Wait.
Excellent.
Yeah.
Good. Blimey. It's not very nice, is it? But let's assume it's not due to mistakes we've made. And then y would equal,
Y would equal to 9 over 2, which is 81 over 4, which is
okay, well,
yeah, 81 over 4. Yeah.
So our coordinates are b is at all of that.
Yeah.
It just have to be that.
Yeah.
I'll have a look later, see, make sure we haven't. But it looks neat. Our
Yeah.
results look neat enough. It's probably what it is. That's fine.
Yeah.